All right. Morning, everyone. So throughout these past couple of weeks, we've been kind of putting you through the basics of actually using SolidWorks, like getting to know what the sketches are, what the features are, where all the tools are. But when you're actually using the software, there's a lot of kind of best practices that you can use that can really make it a lot easier to work with your parts down the line and make it a lot more organized to actually work with your parts. So if you're on body, you might have seen John, our old dynamics lead's best practices video that Esther sent. I don't like that video very much. It doesn't cover a lot of pretty important things, and it kind of covers a lot of not important things, and it kind of rambles a little bit, and it's not very useful, I think, as a best practices video. So we thought today we'd kind of give you guys a complete list of things you can do to kind of make design a lot easier on yourself and on your teammates and yourself in the future. And you're going to be revising parts because, right, in engineering, we're almost never going to get it right the first time. There's always going to be revision or changes that need to happen. And we want to make that process as easy as possible. And that's what a lot of these best practices are about. So with that, let's get started. I have just a list here, and we're just going to go down the line. We're going to kind of review what each practice is. And at the end, we're going to make a part, one with all the best practices in mind and one with just kind of in the boring, lazy way. And then we're going to make a change to that part and see how that process kind of differs between the two. So with that, let's get started. So the first thing that's really useful to do is to enable dual dimensions. So, for competition and for a lot of just scientific calculation in general, metric system is really nice because every unit's in the power of 10. So it's a lot more convenient to kind of convert between units and calculate forces and everything. But living here in the United States, a lot of our standard things that we can buy, like bolts and tools, are labeled in inches. So for example, like we'd really want to measure everything in millimeters so we can easily calculate the length of a lever arm in meters to find the torque on something. But in the US, if we're going to get a bolt, it's going to be a lot easier to get a half-inch bolt than an M8 bolt, which is an 8 mm bolt, right? So with that in mind, there's something that really useful we can enable called dual dimensions. You go here, you go to tools, or sorry, I'm at my bad. You go to evaluate, measure, and you click units and precision here, bring up this menu. And if you click use dual units, check this box. It should check it for your SolidWorks in general, not just this document. And if you have the other custom settings bullet or option selected, I'll give everyone a second if they want to do that themselves. Sorry, it's under evaluate and then measure. Oh yes, that's another useful thing. There's a search bar here. You can search the names of features or tools, and they will come up for you.
You want just want to pull up the measuring tool so you can just pick up search and then even faster you can just hit S and then it takes you to a search command. And then they can measure it.
There you go. Yeah. See, everyone has stuff to learn, even me. But if you've enabled that setting, you'll kind of see that. Let's open up a sketch here. Let's just put a line and say we want the length of this line, right? Oh, this zoom interface is kind of covering it up. You can see, right, we have the length on the left in millimeters in black. On the right, in like blue brackets, we also have that dimension in inches. That's just going to make it a lot easier to check your dimensions and measurements. Like say, a hole is supposed to be 1/4 inch. You can quickly highlight it instead of converting from millimeters to inches. You can just kind of see that it will the exact value in inches. So something very useful to have enabled in general. Moving on to the next thing that we really want to do is we really want to fully define every single thing in our sketch. So what does that really mean? Let's draw a center rectangle right here on the origin. So you see right now, all of these lines are blue. What these lines being blue means is that if I like hold this point and drag it, I can change the dimensions, right? Now this could be kind of useful when you're still putting the part together initially, but imagine you have a completed part. Like I can take this and I can extrude it out and it looks fine, right? Or it's a square, it's a rectangular prism. It looks like what it's supposed to. But at any point in the future, if I need to change this, or like say someone just opens the sketch and accidentally moves the line like that, just like say they're trying to get the location of a point, they accidentally drag it a tiny little bit, well, that changes the whole model. That's something we really don't want because any mistake like that is really easy to miss and can kind of carry over a long time and put issues that we don't want. And in addition, it's a lot harder to kind of get the exact dimensions we want. For example, like say we have this is a certain distance. if we accidentally drag this a little bit, that distance will change. And that's something that can really cause problems in the future. So we want to make sure that everything is fully defined. And we have two main tools to do this with. So first we have Smart Dimension. Smart Dimension, you can basically select it, and then when it's highlighted, you're in Smart Dimensioning mode. You can select pretty much any two elements, and SolidWorks will do its best to figure out a relation that they should have. For example, if you click two parallel lines, SolidWorks will say, oh, okay, you want the distance between those parallel lines. You just click one line, SolidWorks will say, oh, okay, it's the length of that one line. If you click two lines at an angle, this isn't set up for this. These are already vertical and horizontal. Just try another angle. But if you click two lines at not a 90-degree angle, it'll say, oh, well, you want to measure the angle there. So Smart Dimension is a really useful tool. It can help you set a lot of dimensions in your parts, which is, as you might imagine, pretty important. The second tool that we have is a relation. So notice if you just click on one part, it'll bring up this menu on the side, and you'll have this little section called Add Relations. So just like for Smart Dimension, SolidWorks will kind of give you some options on what to pick for Add Dimensions. So this rectangle is pretty well defined, but let me just add a line here, right? So that automatically put a relation. Oh, okay. But let's say we have this line and this line, and we want them to be perpendicular. We can click this line, hold Shift, and click this line, right? So now you can see we have both of them selected. And then we have all of these different options. We can make them collinear, which basically puts them in the same line. We can make them perpendicular, right? Which, makes them perpendicular. We can put them parallel. In this situation, it's pretty similar to collinear, but if, say, it's not coincident here, notice we can move it to the side, whereas if we do collinear, if I can select it, then we can't really move it off the same line. So with Smart Dimensions and with relations, you should be able to fully define your shapes at all times, and that's something that something that we really want to do, right? You can see now that the square is fully dimensioned, we have the length of that top one, the length of that side one, and that we have an automatic relation that these lines are vertical and these lines are horizontal. So there's no really more wiggle room for the part to move. Yes, Esther. All right. So yeah, you can see these lines once they're fully once these lines are fully defined, you can see they turn black. That's something we really want, because now when they're black, we can't drag the lines around anymore. We have to edit the actual dimensions and the actual relations in order to get them to change. And that's useful because remember the problems before was we could accidentally move these lines when we were trying to measure something. Now we can't do that anymore because if we click and drag, nothing happens. And so yeah, that's the main reason that we want to fully define everything. In addition, say we want to make this 30 millimeters longer in our design. Well, this is a lot easier to say plus 30 millimeters and have it automatically do that versus if it was just blue lines, we'd have to kind of see how long it was, then add 30 to that, and then measure that out. It's a lot more of a hassle. So with this, it makes it a lot easier, and it will kind of tie into some things we'll go into later. So next thing we want to kind of talk about is to use as few features as possible. Right, so say I have this rectangular prism and I want to cut a hole out of the center. Well, a way I could do this is I can say, well, I'll make the body, and then on the top, I'll make another sketch, and I'll draw out a hole. I'm not used to center rectangle. Draw a hole. And then, of course, we want to dimension this properly. So let's say just make this 10 millimeters on all sides. That is not what I wanted to do. Okay, so we have this now, and then we could, to make a hole, just kind of make a cut out of the center, right? That's one way we could do this. But in the future, like this part is relatively simple. We only have a couple features, so you don't notice. But when you get to really complicated parts that have a lot of cuts and a lot of different profiles and a lot of things that are going into them, like having all of these extra features in your bar will make it a lot harder to navigate and figure out what's going on. Like now, if I wanted to change what size the hole is, I'd have to go into this sketch and change that. But if I wanted to change how large the big block is, I'd have to go into this sketch and do that, right? And change that sketch. So this solution works, but it's going to be a pain in the future if we have a lot of things to do. So what's a better way to do it? Well, we can, instead of making a cut there, later. Yeah. Instead of doing that, we can come into this sketch, right? And we can just, that is the top one. And we can just draw our offset box in here. And you'll notice in Sketch, we actually have a lot more tools that make it a lot easier to do this kind of offset shell. Like for example, we can set it to 10. Like before we had to set all four sides, now we can set it to 10 millimeters on each side. And the box will be there. Or even easier, we could use a more advanced tool like offset entities. Highlight the box. Except this. Oh God. Unfortunate. Yeah. Hello. Offset entities. And then do 10 millimeters and do it that way. So it'll make it a lot easier in terms of sketch tools for you to edit these dimensions. And it'll make it a lot easier in the future. So you don't have to pile through twice as many features in order to make sure that everything you need is editable. So kind of jumping off of that, another thing you can do to kind of manage the number of features you're going to have is to name your features. So right now, when you make a feature, it'll just have the name. So it'll be boss extrude, and then it'll be a number for the number in the series. This is fine right now. When you have 30 of them, it's not so fine, and you have to figure out which one is doing which. It's a real hassle. Now you can kind of highlight and click on them, and it will show you what feature it's going through. But if you have to scrub through the entire list every single time, it's going to take a lot of time out of your work. So something you can do that's a lot easier is if you right click, you'll notice there's a lot of options that you can do to the feature. One that we're going to talk about right now is if you just click and then click again, just like you're renaming a file, you're able to rename your feature. So you can rename your features. It makes it a lot easier to find what you need to find in the future. And so yeah, that's just something that's very important to do. Another thing that's important to do is once you get a lot of these features, even if they're all named, sorting through the list is going to take a while. So you can put features in folders. If you just right click and add a new folder, you'll make a folder. Obviously you should name the folder to folder. But then it'll kind of compartmentalize a lot of your features. So say in the future you have a part that has a lot of things and you have like 4 folders, it'll cut down the number of things you have to search through by a fourth if you can just go to a folder and open it and then find a feature within there instead of going through all of them in a big list. Renaming bodies. Huh. Oh yeah. Yeah. You can also name bodies. There you go. That's mainly in assembly though, isn't it? Yeah. I think we'll hold off on that. Yeah, try to keep your part models as one part. If you want to put multiple together, you usually want to do it in assembly because it gives you a lot more flexibility in putting it together. Yeah. Oh, something I didn't forget on my list, but is very useful. If you hold right click and you drag your mouse around, when you're not in the sketch, it'll snap you to a certain view. So it's pretty useful for getting into a view you want. When you're in a sketch, it will pull up some common features. So you can see here, we have a line, we have the corner rectangle, which I know Esther does not appreciate, but I think corner rectangles are great. You have the center circle and you have the dimension. So these are some of the most common tools you're going to be using while sketching. And it's very convenient rather than going all the way up to the bar, clicking smart dimension, and then doing something over here. It's a lot easier just to hold right click, drag up, and then have smart dimensioning tool. It may seem like it's really small, but when you're really in the workflow and like kind of thinking on your feet while you're doing things, it makes it a lot faster and there's a lot less interruptions in what you're doing. So I did want to give a quick example of why like naming features and feature folders are important. Bear with me, this filing system is a mess. But if we go into frame, this is Nathan's frame. Nathan in the back is our frame lead. He did a very good job of putting things in folders and naming them. As you can see, huh? Don't click on tubes. Okay, most of the stuff, right? It's in folders, and you can see like these sketches are named. So if I'm coming in later, I can see exactly what these are referring to, right? Like I can go in the roll hoop and see, oh, this is the sketch for the back roll hoop. This is the sketch for the front roll hoop. It makes it a lot easier. Let's contrast that with what we did last year. If we go to ignore the filing, it is an embarrassment to me every day. Where is it? We look at this part. All right. So can someone find me the feature that makes this cut out? I guess it does that. But right, like you can see how this is a lot more of a coming in later. It's a lot more of a pain to work with this, right? Where I have to kind of search through all these different things that do all these different edits to the body that aren't organized in any way, shape, or form. Then this, where I can go, oh, okay, I need the roll hoop, I need the front roll hoop. Here's a sketch, right? So with that, let's keep on going on. Fillets. Now, fillets are something we talked about a little bit last week. Basically, the motivation behind a fillet is if you have a corner, it creates a stress concentration, and like you'll get into it a lot more during leave your materials class. But the gist of it is right. Stress is force over area. It's a pressure, a fillet. So that means if you have a very small area with the same stress, that you're going to have a lot more. If you have a very small area with the same force, it's going to have a lot more stress. And a corner, well, notice goes to basically nothing in terms of area. So it's going to have a very high stress. The way we combat that is with something called a fillet. I can pull up my shameful old model. You can see these corners. A fillet is basically take a circular cutout and you put a radius on every single corner, so you avoid that concentration. There's a couple ways to do fillets. You can do them in sketch, or you can do them on the body. I can show you both. And generally, it's a lot better to do your fillets on your body, although there are some cases where, say, your fillet radius could cause some errors that you want to do it in the sketch just to make sure, or if you want to visualize something with a fillet, because it can be hard to do that without having an actual fillet there. It's fine to do it in a body, but in general, you want to do it as a feature. So anyways, in a sketch, you can see we have sketch fillet up here as a tool. You click it and you can either click a corner and have it kind of show you a preview of the fillet, or you can click two lines and it will show you like the fillet's going to do, or you can, I think, click a whole rectangle. Never mind. Okay, only a vertex or two line segments, and it will do that. You can set the radius of that fillet. That's basically, you can see this is a like part of a circle. The radius is just the radius of that circle. So you can do it in sketch. I'll do on the outside in sketch here for demonstration purposes. And I'll keep it a 10 millimeter radius. Hit enter, and you can see it automatically changes it. You do have to be careful on a lot of these. When you put a sketch fillet in, it can mess with a lot of these dimensions you put in beforehand. Like this dimension is set point to point for these construction lines, so that's fine. But if we had a measurement that was just on a line and we put a fillet, it kind of deletes the ends of that line, so it makes that dimension kind of invalid. Hey, Danny. So we need to make sure that you're not going to error out. So that's a sketch fillet. You can see we filleted the sketch, so when we actually extrude it, it creates this. The other way we can do it is in the actual body. We can do a fillet feature. So we can have a fillet feature here, and it works a lot in the same way. You can either select an edge, or you can select the whole face, and we'll fill out the whole face. Try not to do the face. It's a little sketchy. You don't have a lot of control. Then you kind of select the edges, just like you were selecting the points before. Wow, I miss. I can't believe I missed. Just like before, you have this fillet. You have a lot more options in terms of how you want to have the fillet go. But in general, we're just going to use a circular fillet that's symmetrical. So I'll do that, and there we can see our parts nicely filleted. Most of our parts, you'll see with this one especially, need fillets because they're taking a lot of load. It's in mechanical, right? In a car, we're going to be preparing the car to hit bumps. So we want areas that are going to be loaded a lot to have pretty exhaustive fillets. Something that does need to be mentioned about fillets, though, you should always do them at the end of the part. So once you have your full body assembled, all your geometry works, and you're just optimizing for stress at that point, that's when you want to put your fillets in. Because if you don't, you end up with something like this. Let's count the fillet features in this part. All right, we have, there's a fillet, there's one, there's a fillet, there's two, uh, there's another fillet. That's three. That is too many fillets. You can, of course, do fillets with different radii, so you'll use different features for that. But in general, I believe these first two are the same radius, and that's just kind of a wasted feature, right? We talked about before how you don't want to drown yourself in features, so adding an extra fillet is just another feature to keep track of and another one to sort through. And in addition, putting fillets near the beginning of the model means that they're kind of baked in. So I'll talk about rolling back in a second, but if we basically go to this point in the part, it's like it has these fillets built in. And fillets do mess with a lot of geometry sometimes. So in the future, if I needed, like, say I needed, what does this fillet do? Like, say in the future, I needed to use this corner in a dimension or something, or as part of a sketch. Well, with the fillet there, I won't be able to do it because the corner doesn't exist anymore in the model. So we always want to do our fillets at the end, and we always want to reduce it to as few features as possible. Ideally, you have one for each radius size. Yeah. It really depends on your application. In general, 3D fillets are going to be better. But in this case, like you can see the center of this upright, there's a lot of fillets, but I did these in Sketch. And the reason is because without that, it's really hard to kind of get the general idea of how much your fillets are actually going to take up. So I guess the whiteboards are not. So let's say I have a really sharp angle, right? Like an angle like this. And I want to put like a tiny, like maybe 10 millimeter fillet on that. Like the fillet could very well be like all the way over here with the size and the small angle. And without having a fillet in Sketch, it's really hard to tell that sometimes. Like I've done it before. Like I've drawn out, pocketing arrangement. Oh, this is gonna be bad. Bear with me. Sorry, Rishi, I know this isn't being recorded. But I've done something like this where it's like, okay, this looks like a fine pocketing arrangement, and then I go to the model and I put fillets on it, like fills in that part, fills in that part, fills in that part, fills in that part, like fills in pretty much the entire block. Which so sometimes if you have a lot and there's small angles involved, you want to check it with a sketch fillet. You might not want to actually use a sketch fillet. But yeah, I cheated on this one. I took the long way where I just took a line, an arc, and made it tangent to both. But it achieves the same end basically.
I guess if you this is probably the best way to go because I think it's a lot easier to dimension.
It is. The 2D fillet tool is a little finicky sometimes. It'll do things you don't want it to do. Doing this kind of thing gives you a lot of control over it, but it does take a lot longer, so it's up to you.
I guess in this case, if you wanted to remove the fillet for whatever reason, then you could just select those construction lines, have them not be construction lines anymore. You can delete the arc. So then if you want to delete a fillet, it's it matches up with your dimensions.
Yeah. Like once you create a fillet, it's semi-permanent. Like if we go back to this part, say if I wanted to like say I wanted to remove this fill, I don't want it anymore. Well, the only way to do that at this point is to like delete this arc, delete this line, delete this line.
I guess you can leave it, you can extend it.
Oh yeah, that's true. Like delete the arc, and then I have to set these coincident again. And that's I have to do that for every single one. And parts usually have a ton of fillets on them, so that's not a great solution to do. But then again, they can save you a lot of time. They can be very helpful. So it will really depends. Everything really depends on how you're going to be using it. All right, something else that's important is so mechanical. We do a lot of simulation, right? And something that the simulation really needs a lot of the time to actually work is a material. And it may seem like a small thing setting the material to what the part's going to be made out of, but in the future, when you're simulating, or if you're simulating an assembly and you have like 20 parts in one assembly, you don't want to try to run it and have a message error pop up being like 10 of these parts have no material, and then search through like all of your parts to see what has a material, what doesn't. You maybe have to ask other people, what are we going to make this out of? Do we know yet? And that's very difficult, or that's not difficult, but it takes a lot of time. It puts a roadblock in between you and doing your work. So we want to just, when we're making our part, one of the first things we do before we start finalizing is just set a material. I'm just going to pick galvanized steel. Galvanized is a cool word, so we're going to use galvanized steel. So yeah, we want to set our material essentially for every part once we push it to GrabCAD. Some more sketch tools to talk about, getting a little more advanced, is dynamic mirroring. So dynamic mirroring, as far as in the way. Like before, you can search in the toolbar, dynamic mirror entities, or you can also find it in tools, sketch tools, and it's right here. What this basically does is, that is a bad example. I'm going to delete this part. Goodbye. That's not a straight line. Okay. So what dynamic mirroring lets us do? Hello, dynamic mirror. All right. What it lets us do is it lets us kind of mirror across the line in real time. So I could say draw a line on this side, right? And you can see it appears on the other side as well. So any part that's mirrored across one axis is going to be very useful, as you can kind of draw whatever you need to. Okay, this part's a little high on the creative liberty, but it'll be a lot easier in terms of you only have to sketch one side of your part rather than sketching each side in turn. And in addition, any changes you make to one side will happen to the other side. It's a lot easier to edit your parts in the future, which is a big motivation behind a lot of what we're doing. Yes, mirroring that's not dynamic is also exists. Yeah. Let me draw a not garbage model for this. I'll just draw a strange pentagon. I guess it's going to be a hexagon now, but you can also go to mirror entities here. You can select mirrors that you want to, or you can select things you want to mirror across a line, and you can select a line. You can also, I believe, delete the old one, but you can also mirror that. This is also an option, but dynamic mirroring allows you to kind of keep track of it while you're working. And in addition, you notice dynamic mirroring had that like left mirror line, so you can clearly see what you're mirroring about. Dynamic mirror will just give you this symmetric constraint, which is really hard to keep track of when you have a lot of constraints on your part. On like a big sketch for the main body of the complicated part, you'll have a ton of these dimensions of these relations, and it's going to be really hard to pick out the mirror. You'll also notice we can't move the mirror line, or sorry, we can move the mirror line, but it's not denoted clearly as the mirror line. So if we have a bunch of lines in a big sketch and we want to move where that line is, where that thing is being mirrored about, it's very hard to find it. Like this one, it's pretty simple. It's relatively obvious that the mirror line is that one because it's mirrored across that one. But in the future, if you have a bunch of lines, some may be overlapping on certain parts. It makes it a lot easier to have that clearly demarcated dynamic mirroring line. So yeah, let me put that rectangular prism back. Yeah. So we talked before about using relations and dimensions. Relations can, oh God, relations can save you a lot of kind of visual clutter in the sense that they don't create the giant bar with a number across your screen. I guess I can show my age-old bad example of this part. If we take a look at this sketch, there's a lot of dimensions, right? And kind of sorting through all of these to find what you want can be kind of a pain. And a lot of these could be, or sorry, I guess this has a lot of um, uh, this has a lot of relations already. But if we use dimensions for every single thing, then there would be like probably 3 times as many dimensions on the sketch, and finding the one you want is even more difficult than it would be in this one. Kind of surprised that one was set up well, I'm gonna be honest. Um, in addition, there are some things that you just can't do with dimensions. So say I want to set these lines to be the same line for some reason. Well, if I do this and I set it to 0, it should error out. Never mind, it doesn't error out. Wow. Okay. I look like a clown. But that creates another issue of like this 0 just kind of there. That's like that's really you can see how that'd be difficult to work with. And having that just 0 floating around in the middle of nowhere, in the middle of all the other features is going to be a pain as well. Let me quickly reconstruct this. Actually, wait, I should work smarter, not harder. Oh, I did have trouble with that. So we can see instead of like creating those construction lines and dimensioning everything, we can select these points, make these vertical, select the midpoint here. There it is. In the origin, make them horizontal. And then offset entities, box, 10 millimeters, offset the other way. Okay. And then you're going to work with me here. All right. Okay. Yeah. I guess this also bears a mention. Anytime you kind of delete and put something new down, um, it doesn't treat it as it just renames those points. It treats it as those points are gone and there's new points with new names in the same place. So you can see this fillet feature. It was referencing all of those edges before that came out of the old sketch. But now with this new sketch, like those edges don't exist. You can see it's still kind of highlighting the old ones and asking where they are. So yeah, we want to make sure when we're changing things that are older in the body that, or we don't want to be making too many like wholly deleting and adding new things, changes in our bodies, because that will create these kinds of errors. And doing this might not be so bad, but doing it for every single sketch or every single feature that follows an early feature that relates to a face or an edge or a corner in one of your old models is going to take you a long time. So you have to go through each feature, change what's wrong. If you do it in the wrong order, of course, if you fix ones at the end before you fix ones at the beginning, or you may change more things that things in the future are dependent on. That kind of acts as a good segue into kind of, actually, hold on. Let me check my list. Yeah, that kind of segues pretty nicely into the next set of things I want to talk about, which is kind of making features independent and rolling back. So you saw before I kind of dragged this blue bar up. This is the rollback bar. Basically, what it does is if I drag it above a feature, like if I drag it above this fillet, it will it will suppress the fillet, which basically treats the fillet as if it doesn't exist. This can be useful in a lot of ways. For example, on this old part again, um, hello. All right, so this is kind of fully complete part. If I want to have a part or have it like if I want to remove this fillet for some reason to do work on this part of the upright without that fillet, I can drag it from before. And now if I make any feature sketch, it will put it basically right at the level of the bar. So it'll kind of be able to insert a feature into your earlier things. The reason I want to do this is sometimes you'll have to delete an old feature. And when you do that, you want to make sure that a lot of newer features that don't necessarily need to depend on it don't depend on it. When I say dependent, it's basically just it references something from that old feature. So say like this main body, right? It has all of these edges and corners and faces. If I have something else that doesn't need to reference this body, and I need to delete it in the future, it will mess up that other thing, even though it won't be related in any way, shape, or form. That wasn't very coherent, was it?
So essentially, you have like an early feature that you want to get rid of, right? But other features are dependent on that. It's a really big pain if you have to go and delete that like early feature because it messes up the other related features. So try not to do that.
I guess I can quickly delete this. Okay. Yes, okay. Do a quick example. Give me 1 second to kind of sketch this out. Well, Solidworks hates me. Why are you doing this? There we go. Really should have had visual aids ready. That's okay. So this is a kind of nothing part. Let's say we have this circle and we have a circle on one side. And to dimension this other one, we go, well, okay, I could dimension it from this big circle, or I could dimension it from that radius. Let's try doing it from this radius, right? What could go wrong? Let's say I should extrude that. No, we'll make it a cut. We'll have some variety. Huh? Oh, yeah. Okay, I'll make it a through hole. All right, so sorry. Then it'll actually be something that you might actually do. It's crazy. But yeah. There's a lot of options for like how you do your extrusions and rotations, especially extrusions. There's a lot of so there's blind where you're just at a distance. There's through all, which essentially punches through your entire model in one way. Roll both does it to both. Up to next, you can kind of select a thing, so that's pretty useful because shoot, I'll do blind for now, and we'll extend it to right there. We'll make that cut. I'll talk about this in a second. Actually, I want to talk about dependence. So let's say in the future, for some unknown reason, I have to replace this with something else. If we delete it, if we hit delete, you'll see. Wait, hold on. It doesn't say all the. Okay, there it is. I was worried for a second. So it gives us an error. Sketch contains dimensions or relations to model geometry that no longer exists. Doesn't exist because we deleted it, right? Now you can see we have a nice error here. And even worse, we have a blue line. It would be a blue. It might be a yellow line from just errors. Let's see. Yeah, it's an errored outline. Aside from being a bad practice and not being related to anything, it's really annoying every time you exit a sketch to have this pop up. It's really annoying. So. Control Z it back into existence. So something Cesar did mention was that using that through hole or that two, not using blind. So yeah. Yeah. Versus if you say, okay, I want to a surface, and then I select this surface. Now, no matter how wide or no matter how thick I make this rectangle, say I make this 200 millimeters, right? It's huge, but that hole will still, if I can find it, Jesus, that hole will still be in the top. So that's a really good practice when you're changing dimensions a lot. That kind of like hole cut through a certain length can get overlooked really easily. And if you set it to be to a certain surface and you constrain it geometrically rather than putting a dimension on it, it kind of future proofs it a lot in terms of things you'll have to change. And then, as we said before, when you're rolling back, I'm going to make this not 200 millimeters tall anymore. If you want to put a feature in a place that you need to remove a certain feature, you can always use the rollback bar. If you're going to be putting a feature in a place that a lot of things will depend on, it's good to use the rollback bar because that will make sure that if you have to delete anything that's not rolled back, you won't affect the other thing that you're putting in this space where the bar is. Like say I wanted to put another another circle here. Love circles today. Yeah. Now, like when I roll it forward, even if I delete this hole, then it will still function and not break. Versus if I put it at the end, there would be a possibility of it breaking just because coming later, it could be dependent on that earlier feature in terms of maybe accidentally relating to a line or maybe being on a face that that last feature created. So yeah.
If you're going to make like parts that are essentially a bunch of base stacked up, please don't use a bunch of extrusions and plus. Just do a roll. Like it's gonna take you a bunch of freaking features.
Yeah.
Yeah, something to do with money.
Yeah.
So yeah, it's really cool.
I was thinking about trying that. See, there's a lovely sound. What happens when you delete things that are dependent? Lovely. Okay, so like Cesar said, we talked before about reducing the number of features we have, and that kind of thing creates a lot. Why is this orientation? Okay, that thing creates a lot of features. So, oh wait, now I should be on the front plane. Oops. Sketch, and there we go. So something we can do instead of that is use our nice tool, the revolve. I know this was kind of covered in your basic like CAD introduction, but its application is pretty important. So like for a part like that, I could have those four features, making those four different parts, and it would work. But instead of doing that, we can do something like I'm gonna do something real rough here. Probably not even match the old one. Hello. I swear this mouse is broken. And then I'm doing a best practices video, and I want to just leave this all blue. I'm in disgrace. I'll leave it blue to my everlasting shame. But instead of doing all those discs layer on top of each other, you can see we can just, that is the wrong one. Revolve ball space. We can select an axis of revolution. I did not put down an axis of revolution. There we go. And we can kind of revolve it around. We can make those stack discs in a lot easier way. Another important thing is instead of like having to edit this disc and then edit this disc and edit this disc, but like if we want to change the height, we can just go into this sketch. We have this side profile that we can edit a lot easier with our dimensions. One last thing I am realizing that I forgot is construction lines. So you all remember geometry from somewhere in high school. And I assume a lot of you did construction. May have seemed pretty useless back then. It was kind of useless back then, but now construction is something that can save you a lot if you, in terms of like not having so many dimensions or doing dimensions that wouldn't really be possible. So like we can see an example with a corner rectangle, right? How it has these diagonal lines that define the center. Without these diagonal lines, it can be really difficult to kind of put something in the center of the rectangle because you'd have to have your point related to the midpoint of this side, related to the midpoint of this side, and then make sure to stay there. But with construction lines, it's a lot easier. You can see another more impactful example, I suppose, is in this part, which I was surprised was set up well. You can see, right, we have these construction lines pretty much everywhere to kind of show this is the minimum radius I want to support that axle. This is like the profile I want my beams to follow. And then you can kind of construct your actual sketch lines around that. Saves you a lot of brain power and a lot of time, and it's a lot more, it's a lot easier to edit in the future. Something else you may have noticed before I get into like, I'm going to go into global variables and simulation and design process. Do any other mechanical people have any tips I may have missed I could learn from you guys?
Well, I mean, there's like, similar to mirror, where it's like underneath mirror, so you have like linear balance and stuff.
Yeah.
You can do linear balance and sketches, but editing them can also be advanced, so if you want to like, do linear or rectangular pattern, you can also do that. I would recommend doing that like outside of the sketch, because it's a lot easier to edit.
What linear patterns are that bad, are they?
With the sketch, or in the sketch.
Yeah.
They're super annoying. I prefer to do that.
Hold on. We're gonna do an experiment. The man of science. Linear pattern. So linear pattern is one of the tools that should have been covered in your work if you did the dynamics stuff. If not, please feel free to correct me. Oops. But essentially you can select directions, number of patterns, spacing between them. Like 4. I do. I'm just like trying to get a sense of the offset right now. Okay. Linear pattern. If you set it up, you have the number. Oh, does it not give you? Okay, yeah, don't use this. It's bad. The circular one is a lot better. Because the circular one, like say we wanted to put a whole pattern in this. You can see under linear, we have the circular sketch pattern. It's a lot easier just because like, let's make this 7. You still have access to all the relevant dimensions, right? So you can you can reduce the radius, you can change the orientation, still change the size of the circles. That's all you really need to change in a whole pattern. And there's a 6 somewhere, or there's a 7 somewhere, you can change the number of holes. So you still have all the tools you need with the circular sketch pattern. It's pretty good. I suppose the linear is not very good though. Maybe. Let's see. Yeah, don't use the linear sketch pattern. That's the moral of the story. All right. So no one else. All right. So that's kind of the basic best practice when you're modeling. In terms of changing and like more rapid prototyping and getting views from design, you'll notice in this part, we have these like red sigmas on a lot of the dimensions. That indicates that we have a global variable there. And we talked a little about global variables before, I believe. But if you kind of open up your equations file, you can see that we've defined some values for the entire model, right? So we have thickness of the trusses, the mounting distance on the top, the hole diameter on the top mounting, the spacing of those holes. So what that lets us do is say I run the simulation on this and it fails. I need to make each of these trusses thicker. Each one of these. I could go into the sketch if I didn't have global variables, and like say, oh God, that's the wrong one. I could say, okay, I'm going to double click this and edit this value. Then I'm going to double click this and edit this value. I'm going to double click this and edit this value. Look at how many 0.2s there are with red sigmas. There are a ton of them. They are everywhere in this model. That one's an actual sketch dimension, but you get the idea. Or if you have global variables set up, I can go in here I can say, all right, make this 0.3 inches thick. And it shouldn't error out because hopefully it's set up well. There we go. It didn't error out. You can see it made all of these trusses a lot thicker. So variables are something that it will take a lot more time to set up, definitely, than just putting numbers. But at the end of the day, when you do have them set up, it makes it a lot easier to make changes really fast, right? Like I can take this and I can make it 0.1 inches like it was originally where it filled Sims. Yay, thanks, John. And now it's 0.1 inches thick. Or I can make them, right, if I want to really make sure it'll be fine, I can make them half an inch thick. And it'll make them half, okay, it did error out. That's what I was afraid of. I can make them 0.4 inches thick and it will hopefully won't error out. There we go. Oh, it still doesn't like it, but yeah, okay. I can make it 0.3 inches thick like I did before and it won't error out. Definitely. Yeah. So that's something that can save you a lot of time in the future editing. It can also, I know I said it'll take a lot more time making the part, but if you have a lot of those global variables, like in this part, then it can actually save you time to set up that global variable in advance. Because, right, I could, let me open the sketch again. I could have, for the sketch, typed 2 on every single one of these. Or like, if it was, and if it wasn't 2, like if it was a non-whole number, I would have to type 2 point and then whatever decimal places. Here, and very, okay. Thank you. That's actually the wrong one. I didn't want to. Oh no, it is the right one. Why? Okay. Here, what I really like to do is just Control C this, and every time I make a new dimension, just dimension and Control V real fast. So it makes it. It can save you pretty much. It can cost you pretty much no time because if you have a bunch of these dimensions, you're going to be the same. You'd probably be copy and pasting like that value anyways. But it gives you that flexibility to change it in the future. Yeah. So. Oh yeah.
That's really useful. Under the equations, like this, you have global variables and you have the equations. And like if you give this, if you name your dimensions like something, and you go under equations, or like if you name your like things in sketches, you can go in under the equations like this, and you can change the dimensions and the dimensions.
I'm going to start video for this because I'm realizing that the people on Zoom could not see the whiteboard from my earlier thing. But say we have like that upright, and we know that this mounting, like these are mounts. We know this mounting distance, and we know this mounting distance. We could calculate. We could have a third variable, like we could have x, and we could set it equal to the difference. That's not a 1. Right. So it's something that gives us a lot of flexibility. You can also, an example that's using this part, if we want to have more flexibility with our trusses, we could take that truss thickness and multiply it by like 1.5 for one that needs to be especially strong, maybe like 0.75 for one that needs to be, that doesn't need to be as strong. So it gives you a lot of flexibility in terms of having everything linked to a certain value that you can edit after the fact extremely easily, right? Like if I didn't have these variables, I could go in and change them all, but with them, it'll take half a second. Yeah.
Well, actually, I was going to mention that you can make one a driven dimension. So it like it doesn't affect the dimension. It just basically shows you like that distance, right? I mean, yeah, I think having driven dimensions is nice. Because like if you want to know the distance between something, but like you don't have to measure it, it just like shows it in the steps.
Yeah. So a great example of that, that's a good thing to bring up, is for our steering geometry sketch for this year. A driven dimension is basically a dimension that just shows a measurement of something. It can be an angle, it can be a length. That's something that we should see in this car, in this model. If it didn't get removed, I don't remember. If we offset that a little bit. Wait, crap. I pressed the wrong one. Oh. Okay, it's not there anymore. Unfortunate. If we set this dimension, it'll error out because normally this dimension would overdefine our sketch, right? If we make it driven, it'll kind of be grayed out and it kind of just shows the measurement. So if I continue to change this length, you'll see it'll show you the measurement even, okay, that's too far, but it'll show you that angle even as you continue to move it. Yeah. Wow, Danny, 0.1 degrees toe out. Can't believe you. Okay. Yeah. Anyone else have anything to bring up before we kind of continue on to simulation, which is kind of a whole different ballpark?
Does anyone else have any questions or any features there?
Oh yeah. For setting up for setting up a global variable, you can search, of course, I guess you can search equations here. And it'll come up there. You can also go to tools and it's there. And that'll kind of bring up this global variables table. It'll kind of list all the global variables you have in your part. You can also, while you're in the sketch, oh God, this part comes back to bite me. I don't have any dimensions here. Oh, I have some dimensions. If you have a value and you type equal, then you type like type a name, you'll notice it turns yellow and there's this little thing that says, well, it says what it says it does. If you click it, it'll kind of define a global variable with that value. You can see if we go back to our equations, it is now defined there with that value. Okay. It's a true CS major variable name. Yeah. Yeah. So dynamic mirror, I think the biggest, let me make a new sketch for this. Oh God, I should have done the circle. So I think the biggest differences are that dynamic mirror will continue to mirror things, whereas the normal mirror will kind of only do a certain set that you select. So let's say I have this box I want to mirror. It will let me draw a box. Hello? Okay, box I want to mirror. And I want to mirror it across this center line. I can hit mirror entities, select the box, select the line, and it will mirror that box. But say I keep drawing on this side, it doesn't actually keep mirroring. It only mirrors that thing I selected, right? Whereas if I put together a dynamic mirror ahead of time, I still need that sketch line. Wow. I don't even have an excuse. I got sleep. I haven't messed with it too much, honestly. Like now, say I draw this box. I keep sketching on this side. It'll keep mirroring on this side. So they have their uses where if you have a part that is truly completely symmetrical, you'll want to use that dynamic mirror because it'll save you a lot of time in the future. But if you have something that isn't, like say you have Esther, can you, oh no, Esther's not here. Walter, can you talk about dynamic mirroring on and off? Can I like mirror this and then make it stop mirroring things I draw on either side? There you go. Let me actually get back to flow. Is it working? It's talking off, yeah. So yeah, if I want to stop, then thank you, Walter. I can just hit it again and it will turn off. Yeah. Advantages, disadvantages. I think once you turn it, oh no, it does stay mirrored. Okay. Learn something new every day. Two options. It really depends on your preference and what you're used to using. I think dynamic mirroring is a little easier to use in general. But yeah. Anything else before we talk about some simulation? Construction, sure. So construction lines, what specifically were you wondering about construction lines? So you can make any line a construction line. Like say I draw this line here. If you right click, you'll see this construction geometry option. If you don't have anything selected, it'll put you in like the mode where you can select any line and it'll become a construction line. First, or you can kind of select a part and then hit construction geometry and it'll just make that part or whatever set of parts you highlight into construction geometry. Yeah.
And they don't have to be like
Mhm. Yeah, and you also have the third option is the center line. That's only for lines, though. I don't think any other sketch tool has that. And like as does our said, you can see that they can be all shapes and sizes. We have one that's a circle here. You can make them curvilinear. Basically, any line can become a construction line if you do this option on it. Yeah. And when it's a line, of course, you can't use it as part of like your enclosed space. So, like if I select this, right, or if I select this, that's not a good example. I should select feature. You'll notice we only have this body highlighted instead of selecting every section that's divided up by construction lines. If I deselect this, that's the whole section gone. Okay. This part. For lines, you can if you're using that centerline tool. It's like I'm on the centerline tool right now, and now every line I draw, I'm not in Sketch. I'm just gonna go back to this part. I select that. Every line I draw is going to be construction, right? Circles, I don't believe there's a way to do that. I could be wrong, but lines are going to be a lot more of what you draw for construction. Like circles, you want usually for a certain radius, but it's not going to be quite as many as lines, so it won't be that as much of a hassle to just turn those into construction circles.
There's some more benefits you can do, like lines you can split them, you can merge lines.
No, it's probably like the scope of it when it comes for now. Anything else before we kind of move on? No. All right. So let's talk a little bit about simulation. We did a real fast like breeze through before. I want to get a little more in depth this time. So let's use our good old friend, the upright here. I'm going to make a new static simulation. Ooh, that's a good question. You know what? We'll do that thing where we make a part with good best practices and bad best practices, and then we'll do it off of that part. I don't think it's going to be a really long talk if I do that. Make it simple. All right, so okay. All right, we have an option here. I can either make a relatively simple part to talk about simulation now and have something you can follow along for simulation, or I can make a more complex part that's going to take a lot longer. And we probably won't be able to use that for simulation just because of the time it's going to take. I'll probably just use the model we currently. No, I'll do it. Screw it. We have time. Yeah, I was going to make an upright, but uprights take a while. I should know. I've stayed up pretty late making a lot of them. You know what? We'll do it. All right. I have with me an actual pre-prepared thing. It's crazy. I'm really a genius programmer. No, we're gonna make one. It'll work. So, how do I? Okay, I feel bad for all my TAs now. How to use this thing? All right, I drew this up last night. This is like probably the most advanced thing you would get in terms of dimensions for a sketch. Usually, what you'll get something that looks like this. Yeah, if you get them at all. Usually, I would give you something that looks like that and say that's your upright geometry. Yeah, I didn't want to do that today because that would be a pain. You can see we have all of our kind of relevant dimensions for the body of the upright that are important to everyone else. So right, we have that distance between those mounting points. We have the height of that mounting box. We have that diameter of the circle. We have the thickness of the part. So with this, we can kind of, that was my mouse pad space. We can make a part off of this. So I'm going to go into that. We're going to start with a sketch. Usually when you hit an isometric view, you want to see like the part in its kind of normal orientation. So for this kind of first profile that I'm going to sketch, I'm going to do it. Oh, I have to switch back and forth. It's going to be fine. I'm going to do it on the front plane. So usually you want to start on the front or top plane. It really just depends on what you're making or how you feel, really. It,
Like, depending on, like, the orientation when you do an isometric, you probably want to have, like, for, like, one, how can I say it? Like, did you take any engineering classes? Like,
in high school, I took one in middle school.
Like, they tell you to, like, orient the parts and voice when you do, like, isometric.
They just taught us to use CAD badly in my class.
Okay. Well, just, like, oriented in a way that makes sense. And, like, whenever you do an isometric, like, you can get a good idea of what the part actually looks like. So, yeah.
Yeah. All right. So make a real basic upright. If you're an unsprung, this is not everything that goes into an upright because I don't want to be here for like 3 hours making this. But we're going to start with a rectangle, right? That's kind of the main body of that upright. Right. Oh, God. I can't half screen this, can I? Wait. If it doesn't work, I have something. Oh,
Which one do you want?
doesn't matter. I don't know how to do that.
I think if you just like, you can just drag it.
Share my document. Is it working? Okay, we're working. Can everyone see both kind of? Oh, I should presume though. Okay. I have technology. If it'll work. I don't know. It worked last time I was here, so hopefully it does. Will it work? Please work. Yes, no. Okay, never mind. Sorry, Zoom people. Real quick. Yes, I can share an image of this right now. Yeah, right now. All right, I'm gonna real quick. I have it muted right now because I'm opening Discord because that's how I send myself files. What the heck is it? Wait, I don't know. Copy image.
Nice. You copy the image, so you can just paste it into the purchase one.
Control one. That's it. Oh God.
Yeah.
All right. Well, I guess that works. Okay. Learn something new every day. Apparently, you can do this. Kind of cursed, but we'll roll with it. Well, it's gonna reclaim my mouse pad space because I like to be cramped. So you can see right, we have these little boxes. We have that 1.5 box height. We have this distance to the center of the axle. But we don't have every single dimension, right? A lot of the times when you're actually designing, you're not going to be given every single dimension because that's if they can give you every single dimension, they could have made the part themselves, and it's not really worth the hassle of the time to pass it to someone else. So you're going to have to be a little creative with a lot of these. So
We figured out, or we found out, unfortunately, that a lot of it kind of have to extrapolate some of the
so one reason I don't like that the center rectangles, it puts those automatic lines there. They can be useful sometimes. There you go. Learn something new every day. Yeah, but a good thing to do to start, I'm just going to go back to corner rectangle, is we can kind of sketch out our preliminary geometry. Everything's blue right now, right? So it's not going to be very useful, but it is good to just kind of give us a general view of how everything is going to come together. The way we're going to do this, we're going to do a main body and we're going to do a side arm. So when I have this kind of together, I'm going to say, I'm going to start looking at my dimensions, right? So I can say, oh, crap, you should have had a center line. All right, so I can start looking at my dimensions, right? This center to center is about 7 inches. So we can set that right now. That vertical distance, make it 7 inches, right? We're in millimeters right now, but that is an alarm. That's very unfortunate. But we can see if we kind of click on this dimension, or not the dimensions, but if we kind of click on these 2 points, wow, I need to get out of that mode. I don't like to do it in the actual like sketch because it makes it really big. So we can see that distance is in fact 7 inches. There we go, dual dimensions. We can see that from that bottom middle to that center of the hole, it's going to be 3 inches. We can put that together. And we can also see that center hole is supposed to be 5/16 inches, even though I didn't put a unit or I cut off the unit. So we can, okay. Did I really put that? Hold on. It's a little bigger than 1/4 inch. I thought it would be a lot bigger. Yes, sometimes SolidWorks will do like, it'll take 5 divided by 16 inches as 5 millimeters divided by 16 inches. I don't know why it does that, but yeah, you're right. I'm stupid. How could I not realize that? This is a little small, I'm gonna be honest. You know what? Half an inch is fine. All right, we're changed. That document's no longer valid. It's now half an inch full. I've decided. Change came in from Unsprung and they want it that way. So we have that basic dimension. You'll notice we still have a lot of wiggle room, right? We can still, these boxes kind of grow and shrink a lot, or I guess we have more dimensions to cover. It should be 1.5 inches tall. That is fun. Right. Sometimes the sketch will interpret what you want as a very strange operation, so it'll do that. Oh, it did though. That's the thing. Maybe I'm just forgetful. Maybe I'm going senile. Yeah, but we can make this vertical. Okay. We can make this vertical. I have to detail the line. God. Right. Okay. So now we can see these black lines are fixed because right, they have the center distance is defined, the height is defined, so these black lines can't move up and down anymore. They're black, so that's good. In terms of our spacing here, let's define a global variable because we're going to have a lot of trusses that are going to be a certain thickness, and I don't want to type that number over and over again. So we're just going to, this bar is really annoying. You know that? We're going to go to equations like before. We're going to do truss thickness. We're going to make it for now a starting value 0.2 inches. Okay, so now that's defined. So now if we take this truss thickness, we define it here. Oh, also something important. If you just put the name of the global variable, then it will just read the value and put it in there. If you change that variable, if you change that value later, it won't actually update in the model. What you need is an equal sign and then the global variable, like that. And then now what you'll do is when you click off of it, it will have that red sigma. That means it'll update as the variable updates. So with that, I'm going to, these are all going to be kind of members in this part. So I'm going to quickly define these thicknesses. Notice we still have blue lines. I'm going to check. That's going to be the width. It should be the width. Yeah. So it's the width of this, right? We still haven't defined this. Let me do that. Why is my computer lagging so much? Oh, it's because I'm not plugged in. That makes sense. My computer is about to die. Yeah. There we go. So we're defined. Yep. Okay. So now we have a lot of these distances set, but you notice like in our geometry sketch, we don't have anything for this distance. So this is something we kind of have to figure out on our own. In a lot of design, you usually just pick a number, you run with it until the number starts to cause issues, and then you change it to make cause less issues. That will break other numbers that you've randomly chosen because they're convenient. But that's kind of the essence of design is you don't have a lot of problems you get aren't fully constrained. You'll have a lot of kind of creative liberty to change them. And in the future, you may be able to tone that in with optimization algorithms and things like that. I'm going to talk about that later. There's a reason I have truss thickness defined. Yeah. I'm just going to set this arbitrarily at 80 millimeters. We have this. Now, this is all our basic geometry, right? We can kind of extrude this 1 inch as shown in the sketch for our main body. But this is kind of terrible upright. The main reason, well, aside from not actually being able to mount anything, is if we go to evaluate mass properties, how heavy is this thing? Okay, yeah. All right. That's true. That's true. Let's do our what dynamics makes pretty much everything out of 6061 T6. Go to mass properties. It's still almost 1,000. It's almost a kilogram. That's like what, 2.5 pounds? It's in the evaluate tab, mass properties, or you can search up mass properties here. So yeah, that's really heavy. One. So we want to make it a lot less heavy. Then we do that something called pocketing, where we kind of cut holes out of our upright in places that's not going to be stressed as much. So in following our best practice, I'm going to go back into the sketch instead of making a new cut feature to cut those. And this is where construction lines can come in a lot of handy. I'm going to first make a midpoint line, connect it to each side. What? Maybe, perhaps. Yeah. We have a good example of how we can use a dynamic mirroring. I have to define an axis. We can dynamically mirror across this line. Delete that. We can go ahead now. Oh, that line is not defined very well. Want to make it coincident. Well, we notice it's blue, so I can drag around. We want it to not be blue. We only want the endpoints to be able to be moved. So right now, the line's not going to move left or right anymore. Take this midpoint line. There's a lot of things on that central point. Draw here. It should mirror it, right? I assume that's not good. So now we've made some construction lines. I just use midpoint line that's mirrored across. We can, from this, kind of draw out some rectangles or some, not rectangles, wow, triangles. Okay, I didn't like that, I suppose. Okay. I'm choking right now. We can kind of draw that central axis is pretty good to have usually on the symmetric part just because it gives you a reference for a lot of centering things. You can draw out a line here. We can use a relation to make it parallel to this line. And then we can use a dimension to make this the truss, half of the truss thickness. And we can do the same thing on the other side. It has issues sometimes with like kind of like this kind of thing where you have to trim entities at. What did that do? Oh, I know what it did. No, no, it's gonna be coincident with this line now. I could not mirror. Interesting. All right, sorry about that. That was a little embarrassment. We're gonna do the same thing again where we draw that line, we make them parallel. We're going to set, why is that set? Right, yes, you're right. I'm trying to mess this up here. All right. Construction geometry. This is the lazy way to, God, I'm doing everything the lazy way on the best practices presentation. I mean, this isn't like bad to do. Oh, I want to date them. And then on this one, and oh God. All right, so finally, after way too much effort, drawn that. We can do the same thing here where we set this parallel with a relation and then use a dimension, set this to half of the truss thickness.
Like if you know two like dimensions you're gonna do the same power, you can take it with another dimension.
Does it do that for global and like updating ones? It doesn't pull the global variable though. It doesn't have a sigma. AP. Yeah. Wow, that, oh my God, okay. So sometimes your dimension will do something a little weird where notice this is actually half the distance it's supposed to be. It's the way it's defined. I frankly have no idea why it does that. But okay, after way too much work, there are trusses on the, I forgot something else. So classic Jacob did again. That needs to be deleted. That is not what I wanted to delete. Wow. Jesus Christ. Just let me delete this, please. Dynamic mirroring is off, of course. All right. We can't have a sidewall thickness of 0, so we're going to make an actual out for the sidewall. Vertical relation? What? Okay. Well, yeah, but like it's a vertical line over defined. I don't know about that one. Yeah. So like I was doing about 5 minutes before, we can. Hmm? If you dimension without making it parallel, oh, it'll make an angle here. Okay, after way too long, there we go. That's one side. Now we can do the other side. Hmm? Oh, yeah. Maybe I'm just revealing that I'm bad at CAD this whole time. You laugh, it may be true. Oh God, what do I do? Did that? Oh, I have the wrong line selected. Just like before, we are making those lines parallel and then setting them to be half our truss thickness. This one did the strange thing where it measures the half, where like measures double the dimension you select as the thickness. I have no idea why it does. It wait, no, that's one one. Why is that not a variable anymore? No. So now we have just kind of basic pattern cutout. You'll notice right now these have no thickness. Like this whole area is slated to be cut out that has no thickness, so we can fix that as well. Horizontal and setting that thickness to be the same as the truss thickness. So now we're about to cut out this shape, this shape, this shape, and this shape. Oh, you can see at the bottom we also have zero thickness line. We don't want that, so we can once again dimension that to be horizontal or parallel. It's the same. Set the distance to be the truss thickness. And now we can see we have these 4 sections to cut out. That will take a lot of the weight out. And if we go back into our feature, it's going to give us an error because we kind of, before it was one central body, it knew exactly what to extrude. Now there's like 5 options for what to extrude. It doesn't know exactly what it wants us to do. So it's going to error out. Yeah, okay. Thank you. Very fun. But if we go to edit feature, this sketch contour part right here, we can select which parts get extruded. So we can select that part, and that part, and that part, and this, and this, and this. So we have that kind of cut that we needed. Okay, I forgot a couple parts. Oops. Wow, today is not my day. Oh yeah, I did, but it's already gone. It's too late. Oh, all right, finally. There we go. Now we have the cuts that we need. I'm going to, like we said before, name this. It's going to be the main body so that we can find it in the future. Now, if you look at an old upright, the way that a lot of these mount is you have these, or this one's missing on the top, but you have these holes in the bottom that kind of let a screw pass through so you can mount it. So we're going to do that as well on this upright. Sketch from the top. We can put this hole in the, we want to put this hole in the center of the face. So something we can either do, or something that we can do is we can define 2 construction lines crossing the center. They meet at the center because geometry. So we can set those to, why does it keep looking to line? Put those to be coincident with the center of the circle, and it will snap the circle to the center, and notice the circle can't move from that center point anymore. We set the radius. Let's say we're going to mount with 5/16. Okay, did it again. That's why. We can mount with a 5/16 hole. So we have that hole centered on the top. We can do extruded cut and something that, so we of course want to do the up to surface, right? And select this bottom surface. So it cuts through both of these. I don't want to do that right now. And then we can put another sketch on the bottom. Yeah. Yes, but I don't want to get that far into. Yeah. Doesn't have to be the last talk. Surface, now we have those. We can name these, of course. We'll name it top. Well, I'm going to ignore the fact that I just tried to spell top with an E. And then these are kind of related, and we might need to reference them in the future, so we can make a folder for them. Name them appropriately. So now if we want to ever edit these holes, we know they're in this folder, and we can see exactly which hole that we're going to add. Full body. Show the body, please. Which one we want to select. So you'll notice in the sketch, this last thing here, this little thing is the steering arm. So we can make a new feature on the side to account for that. We did talk before about kind of reducing the number of features you have, but in certain cases where it's something that's like really its own independent part, it's not a bad thing to have that extra feature just so it's easier to edit that thing individually. Like I could have easily had this in that original sketch on the main body, but it would have been a lot more difficult, a lot more time consuming to edit that steering arm if I only needed to edit the steering arm. So just like with everything, unfortunately, there is nuance. There is no one way best solution all the time. You're right. Yeah, this other. Stop being smart. You're making me look stupid. Is nothing to talk? Hmm? Great. Our view is the okay. I was gonna make it like a progress thing. Yours still right there. So once again we can put kind of a center line, put it on the center point and make it horizontal there. This one I'll actually use the normal mirror instead of the dynamic mirror, so we can sketch that. Wow. That was an accidental F12 hit, I think. And use the mirror entities, select these lines and mirror them about this line. That didn't change. Wow. Please work, mouse. We have this, right? We can see it'll change with the mounting. We're going to define everything, even though I don't have dimensions for this, just to make sure that it's set in a certain way. All right, that's mirrored. Yeah. I'm going to select the origin here. It will not select no. Yeah, it's on the top part. You know what? I will do a sketch dimension from the bottom. And this thickness. So now the whole sketch is black except for this point, which isn't actually part of our model, so it's fully defined. We can't accidentally drag anything. Now we're going to extrude this. I'm going to make this to the surface once again. And then we're going to put a hole in this top part so we can actually mount a rod end inside. Make this 10. I'm going to make that I'm going to make these horizontal. Why does it keep sucking? And then we're going to set the radius to be, or we're going to set the diameter to be, once again, 5/16 inches. If we want to 5 inches. We're going to cut, and we're going to cut all the way through both sides with up to surface. So even if we change that thickness, it will stay the same. And now, right, these two are kind of both on the steering arm, so we can make, or we should name them first. And then just like before, we can put them in their own folder. So now we come back in the future and need to edit the steering arm. It's all in the steering arm folder. More importantly, if someone else who isn't you and didn't put this model together and has no idea how everything is put together comes in, they can edit the steering arm very easily by going to the steering arm and seeing what each feature does. So yeah, that's our basic model. That's with good best practices. I don't want to make one with bad best practices because it's going to take a super long time, and this presentation has gone on for a while already. You can see a lot of the bad best practices exemplified here. So for some ungodly reason, the sketches have been separated from the features. Nothing is named. We have multiple fillets. Oh yes, fillets. Yeah, that thing. That's important that I forgot. That would come up to remind me in simulation. We just want to select most of our profiles. This is where you need to consider manufacturing, which is, yeah. On the steering arm. So what I did here is I essentially put a line here that kind of defined that length. And then I found the center, the midpoint of this line. If you highlight it, just like yellow box color, that's the midpoint. I selected that in the center of the circle. And I made it horizontal. Basically means it'll line up on that x-axis. And this one. So on the top, I think I used a different, if I remember correctly, I used a different technique. Yeah, you just coincident. There's a coincidence between that intersection and the center of the circle. So they're on top of each other. Wow, I didn't expect to go through this thing. It's been like an hour and a half. Yeah. All right. Fillets. Fillets are going to be at the end, of course, because, or not, of course, it really depends. I shouldn't say that. But we want to try to keep fillets condensed in one feature and try to keep them from interfering with other features. You can see, oh, right, manufacturing. So a lot of this is going to be done on a CNC. It would be nice to do a fillet on this edge, right? But that's not always going to be possible given our manufacturing capabilities. I should mention this. I know this is very rambly, but it's kind of a organic thing. Sketch fillets are useful in this situation, very useful because you can see these lines are very close together. What happens is if you try to put one on both, it'll kind of error out because it wants to do that full half circle on both, and it can't do that when they're so close. So if I try to put this with any reasonable radius, it's going to error out. So we'll skip that for now. Yeah, and you'll see it'll do the same thing on this one. A good way to tell if it's going to error out is you have these two lines selected, right? You'll notice right there, it's showing a preview. You select this one. Oh, why did it not do that before? Okay. On this one, you could see if you select this, it'll show you a preview. Select this other one, it deletes both previews and there's nothing there. That's a good indication there's going to be an error there. Oh, I mean, like, yeah. We're going to finish this off by just selecting all of these edges to fill it. This bottom one's going to have the same issue as the top one. So we're going to skip it for now. I was just going to go on the top and bottom. Yeah. You can see this is a good example of the thing I was talking about before with a small angle. You can see it's coming down and taking out like pretty much half of that area. And if we do the bottom as well, I'm going to take out like another third of that area. So that pocket's going to be a lot smaller than we intended. Something else to consider in terms of manufacturing is that everything that we cut out, we're going to cut out with an end mill, right? Which is basically a drill bit, but it can cut sideways. The thing about an end mill is a circle, right? So it can only cut a certain radius on the inside. Like if you have an end mill with a 1/2 inch diameter, I'm trying to cut a fillet with a 1/4 inch diameter, it's not going to fit inside, right? It's only going to be able to go to where that 1/2 inch diameter would sit, and then we'll be able to cut out that final section. So that's another reason we put a lot of fillets on our parts is to get a more realistic view of how it's actually going to come together. Like on this part, if we didn't expect that like a much reduction in the size of the pocket, then it could create issues later when we're like actually making the part or having really different results from simulation. So I will finish this off. I will try to click as fast as I can. That's everything. I actually should fill out these as well. Oh God, not a pleasant view. All right. I forgot one. I should do. Ugh. I'm gonna select all these outside corners as well. Yeah. Yeah. But it also removes stress concentration. So this is an awful view, but you can see we have our original drawing and we have our part that we've kind of created off of that drawing. We've used a lot of our best practices. We can just, I mean, fillets are usually pretty self-explanatory. We can call this in case we have multiple, but if there's only one fillet feature and only one set of fillets, it's usually pretty obvious. For this part, sketch fillets are useful because as we said before, it doesn't really work in the feature fillet. And I believe this won't work either if we just do a sketch fillet and select this and oh, that'll work. So okay, yeah, that's one of the reasons you don't want to use sketch fillets. By doing this, it'll kind of delete a relation that we don't want to delete. Yeah. Yeah, I was gonna do the arc. So a way we can do a fillet kind of manually is we can put a circle not arc, circle. Perimeter circle is usually good for this because you can select points it's tangent to. So we can make it tangent to both lines. And they're going to kind of just go anywhere because we're going to define the radius of this. All of our other fillets were 10 millimeters, so we'll make this 10 millimeters. We'll use this tool called trim entities, which basically deletes a line where you drag through it. So you have a nice fillet there. And then we can do the same thing on the other side. Let's see how fast I can do it. That is not correct. Wow. Slow, smooth, and smooth is fast. There you go. What is going on? Okay. All right, so now we have those fillets on both sides. It probably will error out, or it won't actually extrude them. You can see we still have that air patch. Let's go back into this feature and kind of select those new regions that we've created. You can see like selecting all these different regions is really annoying. Something else that we can do. Oh no, it's going to destroy everything, I think. We can try it though. I really don't want to do it. Nope. Is we can use trim entities to kind of delete a lot of these lines. So we'll combine all of these regions into one. I'm holding my breath until it errors out. Oh, okay. We can deal with that. It did. I lost that coincident constraint at the bottom. This is the one I'm worried about. Yeah. So we can, when we make that sketch geometry, these aren't connected anymore by anything. So we can make some temporary arc or some, wow, I hate how it that. We can make some arcs to kind of fill in the gaps to keep those regions separated. Well, okay, it's not consistent. That's the thing. If it was consistent clockwise for the minor arc, I'd be fine. But it's not. So we've made that construction geometry and we're using it kind of as a template. Kind of just draw some minor arcs to kind of cover it up. You can see those are all blue. A lot of these are no longer blue because we lost a relation. So we can simply do it again. Crispness. Okay. What's wrong? Oh, right. Okay. So now we've kind of cut out those lines. It's fully defined. It should error out on us, right? Because we had a bunch of things selected that don't exist anymore. SolidWorks doesn't like that. So just go back in here, delete all of this, and we should be able to just select this. And now I notice the whole area highlights up. It's a lot easier to manage later, although it does take a little more work while you're doing it. Okay, why did it not do that? Some kind of joke, kind of prank. Huh? Right. Yeah. Doesn't exist. This relation. So that lost a relation when we lead to that point where they intersect. We just need to make it parallel to this construction line, and it's all fine again. It's going to error out again because yeah, we did something it didn't like. Oh right, the error is now in the fillets because we're filling a lot of edges that we deleted and put back in, and when we delete and put things back in, SolidWorks doesn't recognize it. So, oh God. I tried. Oh crap! What the heck? Yeah, no, that's me. Wholly incompetent. So what happened back there is since we kind of deleted those sketch lines and made new ones with new relations, SolidWorks doesn't recognize them, even though we never actually deleted the physical lines, which is very annoying. And it only did it on the top for some reason. I don't understand this program. I'm going to be honest. This program mystifies me every single day. So there we go. We have our part. This is set up with pretty good practices, right? So say we like bring in someone who's never worked on this part of sheet before, and we say we need to make the upright, we need to make the mounting distance that's much taller. Well, okay, that's part of the main body. Go in here, here's a sketch. Oh, here's the dimension I need to edit, right? That makes it a lot easier to change things. And let's say we run the sims, which we'll do in a second, say, oh, the truss is too thin. Okay, we can go in here and make this 0.3 inches. Hopefully it won't error out. It's going to error out. Please don't error out. Okay, it didn't. Thank God. So, sorry. That's kind of all of our best practices coming back to help us in the future. Now I'm going to set this back to 0.2 inches. So now simulation. Simulation is a big part of our design process. So usually when you're designing, I'm going to turn the camera on again. So I'm going to draw. We start with like usually preliminary design. I don't know what to put in this box, but usually like you define all of your things ahead of time in like a thing you're going to start with. So you do some design process we just went through to make that upright, right? You go to evaluation. For us, that's going to be simulations, right? You kind of test out your part. You kind of predict how it's going to work in real life. From there, you kind of I'm going to call this one simulate because I'm going to use evaluate for this next one. So you take that simulation data, you take those mass properties, you take like your buckling simulation data, your stress simulation data, you see what areas need to be reinforced, what needs to be changed. You talk to other people, they might give you some other ideas. Evaluate, and then from there, I guess you just go back here. You go back to design, and you change your design. You make the change you need to make. You make your design better, and then you keep going in this loop. And this loop is never done. You're never going to finish this. Your part can always get better in the future. But once you reach a certain point of you get diminishing returns on your improvements, that's when you can finally break out and stop working. So I hope people in Zoom can see this. This is your kind of loop as an engineer for pretty much any project. Design, a lot of this is CAD, a lot of it is like that drawing that we showed earlier. A lot of it is making that drawing, figuring out what those dimensions actually have to be in that drawing. Simulating is what we're going to talk about in a second. Evaluating, so we're going to talk about how to interpret your results of simulation and things to look out for. And then you go right back to design and edit it. And then you go back and you go back and you keep going. So yeah, now we're going to do some simulation talk. So probably the most important thing for a lot of our mechanical systems, because making parts in real life, of course, is going to be ideal. If we could design a part, then make it and then test in real life, it's going to be a lot more accurate than anything we simulate because it's in real life. That's how it's actually going to be used and how it's actually going to perform. But making things in real life, I'm sure anyone on the dynamics team or the body team specifically can tell you, takes a really, really long time. It's really expensive. It takes a lot of logistics and effort and money and time and expensive equipment to do it. So we want to be sure that when we're making something, it's going to be pretty much our final product, because making something, testing in real life, making edits there, and then like doing it over and over again it's awful. And I should know because I did it this summer. I did it 3 times and it was not fun. So simulation, what are we going to do? This tab is really annoying. Can I hide this? Probably, I don't know. We have a whole tab here for simulation. And new study we can kind of make in new simulation study. There's a lot of different versions, right? We have static, frequency, topology, design, thermal buckling, all of these. A lot of us are going to be mainly using static, because static is just what happens to a part when we have a certain load on it. If you've taken solids, you'll know that a metal can deform a certain amount when it has a certain pressure. So that's kind of what we want to calculate, how much it'll deform, if it will yield, which is permanently deform and not spring back after it's deformed. And that's what the static study is all about. So the static here, we have all of these different things in this sidebar. They're all relatively important. So this static is just your header for what the simulation is. Here you'll have a list of parts if you're in an assembly. Oh yeah. Oh yeah, this is still part one. What? That'll never happen.
If you're making stuff that you know all the shit that like essentially paper even scratching all that.
No, no, that's never happened. No. Um, okay, I wanted to. Okay, wow. Why is this erroring out? This was fine the other day. This was fine literally last night. Anyways, so like this tab right now, it's just this one part because we only have one part in here. We go to this, which is supposed to be working. I have no idea why it has rebuild errors. You'll see this is a full assembly simulation. There's a lot more parts in here. So, and sometimes you don't want to simulate a certain part. Like SolidWorks has trouble with these frame tabs. So I put them there for construction and everything. But when we actually have the simulation, I can remove them from simulation. You can do a lot of things. You can treat them as a beam, treat them as a remote mass. So that's what that kind of tab is. For single parts, what you'll mostly be starting out with, it's just going to be your one part in there. All right. Connections and connections, once again, is something that's mainly going to be important in your assembly simulations. And we can see here, I have some connections in terms of bolts that I didn't put in as models for something I'm not going to get into right now. But I have these bolts as actual connectors in SolidWorks rather than putting a model in there. So that's what the connections tab is. Of course, when you have one part, it's not going to be as prevalent, but it's something to keep in mind. You have the normal options for connectors. You can go through that on your own time. Fixtures is going to be something that's pretty important for your simulation. Basically, the way it works is SolidWorks will apply a force on the object with external loads, and it will hold the object in fixtures, right? Because if you just apply a force on an object, F equals ma. If you don't have something holding it there, it's gonna leave. So if we need a fixture that's going to keep it in place, the way you define your fixtures is really going to depend on your situation. For this, it's an upright, and the main issue we're concerned with is a bump kind of going up from like hitting a rock, say. That will push the wheel up, which will put upright up at that point. So we have two options. We could either kind of constrain the upright where it's mounted to the frame like this, and then put the bump in this going up, or the bad way. We could constrain it where the force is and put an equal and opposite force in the upright. Don't do this, please. Generally, what you want to do is you want to treat the force where the force is actually acting and put the fixture where the fixture is actually acting. I know that sounds kind of stupid to say out loud, but generally it's going to be closer to the frame is where you're going to have your fixture. Because if you treat this in our suspension, we lock the suspension up, then those points are essentially fixed. So we are going to select face. I should just put lens. We'll talk about that in a second. So right now we have it's fixed on these inner parts. But you'll notice, like, if we have an actual upright, I have much here. I wonder. Hold on. You can see I'm very organized with this presentation. Maybe. Nope. You can see it on here, perhaps. Yes. So you can see the way we're treating it right here is kind of that we are holding the entire upright by those inside portions. So that's kind of like we have them threaded. But in real life, it's more that we have a well, not an assembly. We have basically a spacer here that takes a lot of the load. So if we simulate it with kind of this fixed setup, it's not going to be completely inaccurate, but it's not going to be quite right in terms of what we're actually going to expect. So the way we can apply a fixture on like a certain part of a face, not the whole thing, or actually, I guess I should show. We might want to select that part, but just like the face, it selects the whole face, which is not accurate either. So let's say maybe we want to, let's say we like make a sketch and we say, let's make this 5 inches in diameter. Say, okay, well, now we have a sketch. Maybe now it will let me do this fixture and only that part of the sketch. No, it doesn't. What you need is a special feature. It's called a split line. It's in this curves section. What a split line does is it will split a face into 2 different faces. So we can select our sketch here that we want to make the split line. Is this circle? Hello? Why it's not letting me select the sketches, please. Work, please. Yes, no. Why not? There we go. Okay, I guess. We can select the sketch and we can select the faces that's going to be projected on. And these two, it's pretty nice it can do, but something else that's kind of nice is it can go all the way through the part and do these faces as well. So if we do that, we can see there's a split line on all of them, and now we can select that face and region independently. I mean, the reason is because we have that spacer. It's what's actually pressing and holding the upright up, not a screw on the inside. So we can now select these faces, and you can see it only selects that region. This kind of simulates what would happen if we had a spacer, say a washer in there. Oh God, this is a mess. And there. So now that's kind of that's supported in a more realistic fashion for what we'd actually expect. In addition, there's a lot of different kinds of fixtures. So fixed geometry kind of just freezes your thing in place. You have a roller slider, which you can, if you click, you can kind of see it'll allow it to slide along the face. We have a hinge, which it's a hinge. You can put on a cylindrical face and it'll hinge around it. As we can see here, this loading case is better, but these fixtures are better, but they're still not quite accurate, right? This is kind of like if we glued the suspension to that upright and didn't let it turn and we didn't let it move left to right on that face. Whereas if, say, the upright gets pushed, in a better view, gets pushed really hard that way, right? It's going to be those bolts that hold the upright in, not necessarily that bottom patch. So what can we do? We can kind of break up this fixed feature into, into multiple different ones. So, right, if we're thinking about the bolts as kind of a hinge that the upright can rotate on, then we can put fixed hinge here, here, and in here, and also here on the steering arm. And when you do the fixture, you kind of see the direction the arrows are pointing. This will only constrain it radially, so it won't prevent it from rotating. It won't prevent it from, but it will prevent it from moving in the X and Y directions. So there's a hinge there. And in addition, we can also put a roller slider here. Because right, these washers on the bottom, they won't prevent the upright from sliding if there's no bolt, but they will prevent the upright from going up or down. So we can put that slider there. Yes, I'm actually realizing I put these on the wrong side. My mistake. I put these on the wrong side. Clearly functioning at the peak of human intellect right now. Yeah, right. Because if we have a force going up in this upright, then the normal reaction force, which is like the force from the contact between the washer and the upright, that's going to prevent it from moving. It's going to be on the top and on the bottom. Put on the bottom, that would be like we glued it there and it's holding it from pulling up. If we put on the top, it's like something that's in the way of it moving up. So we want to put the split lines on the top. My mistake. It's probably going to error out on me. Yeah. Yeah. Okay. I know. Thank you. The fixed hinge. So the fixed hinge is going to be on these inside faces, right? Because if we treat those as a hinge, like the upright can rotate around them, but it can't move from that. Sorry about that. Going to change the split line location. Yeah. All right, we're all good up to here for people who are following along. No one said no, so I think we're good. For external loads, normally we have in dynamics, if you should know this if you're in dynamics, we have a 5G bump, 1G turning, 1G braking. We're just gonna do a 5G bumping load for simplicity, and also that's the greatest load here. So we can apply a force on this face. Normally when you apply a force on the face, the default is normal, or in terms of a circle, it's gonna be radial. You'll notice, right? If we want that bump, we want it to be in the vertical direction, and this is radial. So how do we do this? Well, let's select a direction where we can, and this may be shocking, select a direction. So we can choose any flat face. We can say, I want the force to be through the plane. And I happen to know from math that that load is going to be about 4,000 newtons vertically. And we can see that from the direction of the arrows, it's going down. But like we said before, if we hit a rock, the load's going to be up. So we want to reverse that direction. Okay. So, does anyone see anything wrong with this? The force being applied on this face, the whole face. Anyone? No issues? We're good? Edward, do you have an issue? Yeah. Yeah. So right now the way it's treated is I'm gonna use my glue metaphor again. It's like the axle glued in, and that glue in the bottom is also pulling the bottom of that up, which is not how it works in real life. Like in real life, it's only going to be that top half that's going to be actually taking any of the force from that bump. So we need to do another split line. This one's a little more awkward. We can put a sketch in that middle part. I think we have a plane there. Yeah. So we have the top plane. We can see the top plane goes right through the middle of that circle. We put a sketch. We can draw a rectangle. We can select this point and make it coincident to this circle.
It's kind of like when you sketches and
Yes. What Cesar said. Why is this? That line should not be there. Okay. So nice blue. Okay, I don't know why this line is blue because it is fully defined, but we're going to roll with it. Yay, bad best practices. So we can kind of draw a rectangle that fills up the center of the circle, and then we can once again take that and exit the sketch, and once again take that split line feature, select that sketch, and silhouette it onto this, so that when we hit enter, you can see we have this line that's perfectly split in the top and bottom halves. So going back to our static loading, we can edit that. Okay, thank you for telling me the error. And only load that top half. That's gonna be more realistic. So that takes care of our fixtures and our load. If they don't have any questions on that, there's a lot of different kinds of each. You can kind of go through on your own time and kind of see what we have in there, what can be useful to you. Any questions? Going once, going twice. Sold to the man in the red shirt. All right. forces, external loads. I have not. I mainly just like calculated it and then applied on a smaller area. Yeah. Yeah. But next important step is right now this is kind of geometrically defined, but the way that the actual simulation works is it takes linear algebra, makes a huge matrix, and then takes that matrix and does a lot of linear algebra on it to get a result. And this is geometry, not a matrix. I don't want to get into it. I don't want to get into it. It's really complicated.
Like, it simulates how each cube is going to, like, what force is going to go through that, and how it's going to be formed, and then it makes it design.
Yeah. It turns into a big matrix and it does math on the matrix. The way you do that is with a mesh. When you create a mesh, you always want to slide it towards fine because the coarse mesh will, yeah, it'll run a lot faster, but the results aren't really valid. So like, is it worth spending like half the time simulating to get an invalid result that you can't even use? I would say no. Most people would say no, unless your task is very, very resource intensive, like say a simulation that took 14 hours to run for no particular reason. You always want the slider to be on fine because you want the most accurate results. What that does, as Cesar said, it divides the part into a bunch of tiny cubes, basically, or maybe not cubes, boxes or little sections. You can see if you zoom in, it kind of shows you what all these cubes are. So yeah, we have our mesh. Your part will not, your simulation will not run without a mesh. So make sure you do this and make sure you set it all the way to fine. The last thing we usually check is your material. If there's no material, the model doesn't know how the metal will behave, so it can't really do the math on how everything's going to deform and what the stresses are going to be. So another reason we always want to set our material early is that. So now we have our part, we have no connections in this. We have our fixture setup, we have our load setup, we have our mesh. The only thing left to do is to run unless I've forgotten something, which would be really funny and I would laugh so hard.
I would recommend saving the setup before you understand.
Oh yeah. I think doesn't it auto save before you run a sim? Sure. Yeah. So yeah, this looks bad. You guys may remember from before when we talked, that's just a form result. This can be useful sometimes to see like the macro effect of where stress, because stress is kind of related to your deformation. So this can show you where there's a lot of stress where, you know, the small variation in color might not show as much. Generally, it's not going to be very useful. We've talked about this bar before. The top is the maximum stress. The bottom is the minimum stress present in the model. Yield strength is the stress at which your metal will fail and start to deform permanently. So of course we want the maximum to be lower than the yield and the fraction by which it's lower. So if you divide the yield by the maximum, you get to the safety factor, which is, you know, by how much your material won't fail given your loads. You can calculate it manually, but it's kind of hard to see where the safety factor is what. So it's good to, oh, I should also say, a lot of your concern is going to be at your maximum stress point, right? So if you right click on stress and go to chart options, I'll pull up this menu, you can show the minimum and show the maximum. Minimum isn't usually super important because you'll need some geometry to account for other forces, but maximum can tell you where there's the most potential issues for your part. You can see the maximum is right there in that section. So maybe if we're going to go through this whole process on the next iteration, you make that thickness a little bigger so there's less stress there. Oh, I did miss the fillets. Okay. Well, sucks for those fillets, I guess. Yeah. And we can also see like where there's no fillets, there's significantly higher stress than where there are fillets. Like here, it's like kind of getting to a little bit of a pretty dark blue-green, whereas here it's pretty similar, no fillets. It's getting into like almost yellow territory. I don't know, I'm colorblind, so maybe not quite. A little bit colorblind. I'm colorblind in the region it matters, just not great. So yeah, that's the basics of simulation. I'm also going to should not say that because when we're going to do a factor of safety plot, this basically does the math for you, where it will kind of for the entire body, it will say what the factor of safety is. You can see if we divide 2.75 by 1.001, it should be about 2.75 for the factor of safety. You can see for the body, it's about 2.75 for the factor of safety. So it's good to know the math checks out. Here, it isn't exceptionally useful. I was going to show it here, but I guess it has an error. Here we have all these different parts. Okay, I know I have the result files. Oh, that's why. Give me 1 second. Okay, now it should work. Work. Okay, it didn't work. I would run it for you. This one takes 10 minutes to run, so I'm not going to do that. But it would, for different parts, it would highlight them in different colors for their lowest factor, for their factor of safeties. So that's something to do. And also something that's nice to do in the factor of safety plot is to show, again, the chart options. We have a few more options here than for the stress. So we can, of course, show the minimum factor of safety. That's going to be important. It's going to match maximum stress unless you have multiple materials. Something else that we can do is we can set a set range for the factor of safety. So we can see like here are the ranges from 2 point, yeah. Basically, if you have multiple parts and you have one that has a super low or super high factor of safety, it can kind of bottom out the rest of the chart by like, if you have like a bunch of data points clustered in one range and one data point super high, this bar is linear. So we'll account for that by squishing all of those tiny ones super close together. It can be hard to tell things sometimes. So we can set a maximum and a minimum value for this factor of safety. On this, I really wanted to show this. That's super unfortunate. But I did. Hopefully it'll let me actually open it. Nope. Maybe? Nope. Okay. But usually it's good to set a minimum factor of safety to show as one, right? Because if it's one or below, that's failing. It doesn't really matter by how much it fails. You just know it fails. Well, like for showing the colors. Like you want to know where it fails and where it's above certain threshold. Our threshold is usually like 3. I'll set it to 5 sometimes just to see a finer, like if a lot of things cluster at 3, it can be hard to tell again. But yeah, you can set the minimum maximum so you don't kind of squash out all that variation because of one really far off data point. Sorry, I couldn't show an actual example. I mean, this thing is not behaving with us. I believe that's everything I wanted to over. Not quite. Okay, so design study. We notice from this, right, our factor of safety is around 2.7. Usually we'll shoot for a factor of safety around 3. So usually we'd reinforce this part somehow. But what we could do is we could go and trust thickness. We could edit this, like, let's make this 0.25 inches and try again. And then run the simulation again, remesh and rerun that. Take a second. And then we have a slightly better factor of safety. But now, like, this is about the range we want. But if you really want to tune in your results, you can use what's called a design study. What a design study will do, it's in this study tree again, it's here. And it gives you a bunch of options. So what you can do is you can set variables, constraints, and goals. So constraints are things that the study will not exceed. Variables are things it's allowed to change, and goals is what it's trying to optimize. So a lot of the time, it'll be your mass of your part. You can see we have a whole bunch of different options here. You have simulation data, mass properties, dimensions, measurement. Mass of the body is a very common one to minimize for your goals, right? We have constraints here. Constraints are what is not allowed to go past. So a very common constraint is simulation data. Hello, simulation data. It's going to be stress. And you can select which simulation it's going to come from. Or I should probably do factor of safety instead of stress, because that's usually more insightful. So factor of safety, with the minimum in the model. And factor of safety, we want to take it from that simulation we just set up, and we want to minimize it, right? So we want it to be greater than, let's say, 3. And then variables, what is allowed to change? Well, we only really set up one variable, and that's trust thickness. So we're going to take the variable. Oh, wait, no. Sorry, let me delete that. Yes. We're just going to set global variable so to be trust thickness. And then hit apply. Okay. So now we have that trust thickness. Okay, it's lagging out right now. All right. But as you can see, right, this trust thickness. Ooh, yikes! What just happened? There it is. Okay, so trust thickness. There's different ways you can set it up. We can say test at these discrete values. We can say test it in this range. We can say test it in this range with a certain step. Let's make this like the minimum 0.1 inches and make the maximum 0.4 inches. And then we can set a step, which is basically how much it divides that region up by. So zoom people. So that works. It has it, have this is our range. We have a step that's this big. It's going to take that step and bring it across the whole region. It's going to test at these points. It's going to test here. Basically, what this design study does is it will take your simulation, run it with this variable at a certain value, get the results, then run it again with a new value. Like it'll run it with this value, get the results, run it with this value of trust thickness, get the results, run it with this value, and keep going all the way down. And in the end, summarize everything in a table and kind of pick out an optimal one for you to use. Now you might notice this step size is pretty important, right? Because if you set a really big step size, it'll run less simulation, saves a lot of time, but you won't get as accurate as tuning the result. If you have a bunch of tiny step sizes, it's going to run a bunch of simulations and it's going to take forever. So what you can usually do, you have 2 options here really. You can set the step size appreciably small and then have lunch while this runs, or that's my usual preferred method. But what you can also do is set a pretty big step size at first, right? And then once you've narrowed, like say you know the optimal values in between these 2 steps, from here you can set the new bounds of your design study to be this, and then make even smaller cuts in there, and then run that again, find like where the optimal range is, and then run even smaller ones until you're getting negligible returns. And that can save you a lot of simulation time if you're able to actively do it. Make sure people on Zoom can see. I hope they could see. I hope I wasn't covering it the whole time. If you're not actively managing it though, and you know you have a big block of time where you don't need your computer and you won't be there, might as well just do it small, you know? Why not? I'll make this step in 0.5 inches just for illustration. So we have everything set up. We have optimization checked. So what optimization means is it basically selects the best version and it sets that variable to that. Yeah. So just be aware that it will change that global variable. It should work unless I've set something up wrong, which is always possible. Let's see. So, right, we have 0.1 to 0.4 with a step of 0.05. Yeah. No, it'll be fine. I've never lost hours of progress before. Maybe this is why I've lost hours of progress before. Yeah, I mean, I usually, this was not far off from what I usually do. Just I go, and it's like a, yeah. So you can see it's running all these situations. A lot of them have failed just because of the fillets, and fillets are fun. And yeah. Another reason you use sketch fillets is they will auto update a lot better with changing variables. Right, like if you had that tangent circle and we set that radius, it's going to perform a lot better than a sketch or a feature fillet, where if it hits another feature fillet or hits another edge wrong, it'll just error out. You can see it's running all of these scenarios. These first four have failed because the body just did not work with the variable values that small.
So, yeah, maybe the vehicle, and the green road, but also when you have to do make your own using,
Yeah. Yeah, we can see it's chosen the optimal value for that fillet is tiny. Um, uh, wait, hold on. Hold on a second. Why is this? I've clearly set something up. Wait, this is bugged. This has to be bugged. Yeah, then okay. Okay, I don't know what this is doing. It says the minimum factor of safety is 3. It is I believe 0.6. Yeah. So I don't know what happened with this one, but that's the design study. It's a useful tool to kind of optimize your designs a lot more. I think that's everything I wanted to talk about today for just best practices and getting the basic of simulation. From here, we could see like, or from before we did the design study, we could see our factor of safety was a little high, so we can make things thinner. It was real, our stress was really low in certain parts of the model. We can make those thinner while keeping others like properly reinforced. And then from there, we can go back to our design and do it over and over again. Walter, is there anything else you're thinking about me covering? Assemblies? You want me to do assemblies? Okay. Anyone have any questions? He's working hard. He's working on the frame. Thank you for your service. Does anyone else and have any questions on anything we talked about today? Or anything at all? Going once, going twice, sold to the man in the red shirt. Okay. Good. Yeah. All right. Thank you, Jacob. Cool.